December 1832. A ship anchors at the southern tip of South America. Charles Darwin is 23 years old, standing on the deck of the Beagle and staring at something that genuinely stops him. On the shore, in temperatures close to freezing, in wind and rain that would send any European running for cover, a group of people stand nearly naked, no hesitation, no visible discomfort. They watch the ship with the same unhurried calm that the sailors watch them. Darwin writes in his diary that night that he has never felt so strongly that he was looking at something ancient, something that had arrived here long before everything else. He couldn't know it then. But he was looking at the people who had traveled farther from the origin point of our entire species than any other human beings on Earth. Here's the question scientists spent decades trying to answer. If you take every population alive today, map where they ended up, and calculate how far they traveled from where humanity began, who walked the most? And more to the point, why does the answer turn out to be so different from what everyone assumed? The starting point isn't a guess. We know, with about as much certainty as science allows, that anatomically modern humans first appeared in East Africa somewhere between 300,000 and 200,000 years ago. The real exodus, the wave that seeded the rest of the planet, started around 60,000 to 70,000 years ago. A group probably no more than a few thousand people crossed out of Africa through the Arabian Peninsula. Everything that came after, every language, every culture, every empire that ever rose and fell is downstream from that single movement. That first step was roughly 4,000 kilometers. What followed took 50,000 years. The way scientists measure migration distance is not as simple as drawing a straight line on a map. That would be convenient, but wrong. The real method is written in DNA. Here's the principle. Every time a small group splits off from a larger population and settles somewhere new, they carry only a fraction of the genetic diversity that existed back home. A few hundred people cannot pack all the variation of tens of thousands, so they lose some. Then their descendants move again and lose a little more, and again, and again. This is called the founder effect, and it leaves a trail that geneticists can read thousands of years later. In 2005, a team led by Sohini Ramachandran published a landmark study in Science. They analyzed DNA from over 50 populations across the globe and found something almost mathematical in its precision. The farther a population lived from East Africa, the less genetic diversity it carried. The pattern wasn't scattered. It followed the actual routes. Humans walked, coastline by coastline, valley by valley, across ice and mountain and sea. You could reverse engineer the entire migration history of our species just from the genes. Every population leaves a signature of how many steps its ancestors took from the source. So who do you think walked farthest? Most people would say Europeans because of the age of exploration, or Polynesians because they crossed open ocean in wooden boats using nothing but stars and currents. The Polynesian navigators are genuinely extraordinary. Hawaii, Easter Island, New Zealand, separated by thousands of miles of open Pacific. That story sounds like the winner. It isn't. And the reason it isn't is worth understanding carefully. The routes that matter here are not the routes of written history. They're the routes of prehistory, the paths walked before agriculture, before writing, before anything we'd call civilization. Polynesians were brilliant seafarers, but their starting position in the migration chain was already deep into Asia. Europeans took a relatively short overland route north and west from Africa. The actual distance for European populations, measured along plausible walking routes, runs roughly 10,000 to 13,000 kilometers from the East African origin. Polynesian populations, reaching islands in the Central Pacific, land somewhere around 20,000 to 25,000 kilometers, depending on the specific island. Those are not the numbers that shock the researchers. To find the real answer, you have to follow the path east and keep going. Groups moving out of Africa along the southern coastal route traveled through the Arabian Peninsula, along the coast of South Asia, through India, through Southeast Asia, and eventually into East Asia. Each of those legs added distance. Each one filtered the gene pool a little further. By the time populations were established in northeastern Siberia, they were already further from Africa than anyone who had moved north into Europe. But they didn't stop there either. During the last ice age, sea levels dropped dramatically, far enough to expose a land bridge between Siberia and Alaska. Scientists call it Beringia. It wasn't a narrow strip of ice. It was a wide, cold, heavily windswept landmass, practically its own subcontinent, and people lived on it for thousands of years before pushing eastward into Alaska. The consensus today puts the first Americans crossing that bridge somewhere between 15,000 and 25,000 years ago, possibly earlier. The debate on exact timing hasn't fully closed, but the fact of the crossing isn't in doubt. And then they kept moving south, down through Alaska, through what is now Canada, across the continental United States, through Mexico, through Central America, into South America, further south, deeper into the continent, down the spine of the Andes, across grasslands, across desert, through jungle, until they reached the absolute end of the landmass, the fractured archipelago of Tierra del Fuego, where the Pacific and Atlantic collide in permanent wind and cold. Total distance from the East African origin point, along the route geneticists have reconstructed, somewhere between 30,000 and 40,000 kilometers. That is the longest human migration ever measured, not close. For reference, Aboriginal Australians who followed a southern coastal route out of Africa and across Southeast Asia before reaching the Australian continent traveled somewhere around 15,000 to 20,000 kilometers, an extraordinary journey by any measure, but still roughly half the distance of the Americas route. The Yagan people Darwin encountered on that beach in 1832, their ancestors completed the full journey, not in one lifetime, not in 100, over tens of thousands of years, generation after generation. The line of descent runs unbroken from East Africa to the farthest southern shore of the farthest southern continent. The genetic evidence confirms it. The haplogroups match. The founder effect bottlenecks are stacked in the DNA like tree rings, each one marking another step away from home. Here's what most people don't sit with long enough. The populations that ended up at the literal edge of the map, the ones that European explorers called primitive, the ones whose cultures were systematically destroyed in the 19th century through disease, displacement, and violence. They were the descendants of the most persistently mobile humans in the entire history of our species. Not the most aggressive conquerors, not the most technologically advanced civilization, just the people who never stopped moving, who kept adapting to conditions that would kill most people inside a week, who made it to the end of the world and stayed there. Darwin thought he was looking at something lower than himself. He was looking at the endpoint of the longest migration humanity has ever completed. The implications don't stop at a ranking on a chart. Genetic diversity decreases with each migration bottleneck, which means African populations today carry more genetic variation than any other group on Earth. Not because of some biological advantage, but simply because everyone else is a subset, a filtered copy of a copy of a copy. The Americas, at the absolute far end of the chain, show the least internal genetic diversity of any continental group. This has direct medical consequences that researchers are still working through. Drug metabolism, immune responses, predispositions to certain diseases. These patterns follow the migration map in ways that actually change clinical decisions when you take them seriously. It also explains why the concept of rigid racial categories falls apart the moment you look at this data. The genetic distance between two people from different regions of Africa is greater than the distance between an African and a European. The variation inside Africa dwarfs the variation across the rest of the world combined. What looks like deep biological difference on the surface turns out to be mostly a measure of how many steps your ancestors took away from one point on the East African coast. Distance from home, mistaken for difference in kind. And that brings us back to the beach. Back to Darwin on the deck of the Beagle, writing in his diary that he couldn't understand what he was seeing. The Yagan didn't need a genetic study to know what they were. They were the people who made it to the end. They had been there for thousands of years by the time anyone from Europe showed up to be confused by them. And in a literal, measurable, scientifically documented sense, no human group on Earth had traveled further to get where they were going. If you know something about your own ancestry's migration path, not the official nationality, but the actual route, the haplogroup, the origin story your family carries, drop it in the comments. I'm genuinely curious what people know. And if you want to understand how geneticists actually reconstruct these routes from modern and ancient DNA, how they read a haplogroup like a passport stamp from 20,000 years ago, that's exactly what I'm building into the next video.